Now we're going to be doing the last part of this program, which is basically if the user decides to exit the program. So again, remember to be on the same indentation as the other elif statements. And then we're going to say elif side to find equals to 4 this time. And remember that 4 from the menu does mean that they decide to exit the program. So we can do a nice thank you message and then just basically exit the program for them if they don't want to restart the program anymore. So what I would like to do is even when they hit exit, I would still like to ask them, are you sure you want to exit or restart? And so if they say yes, I'll say, are you sure you want to exit or restart? Yes to exit or no to restart. Just to be sure if they want to use this program again and still stay in the run of the program. So I'm going to print a nice message over here and I'm going to get a different color to do this. And I will just like to copy my color code right here and then just paste it inside here as well, but then use a different color code. So I think I'm going to go with 142 for this one, just to make it look nice and diverse. And so I'm going to do that message saying, I would just call this and, create a variable first, and then I'll create another statement here saying, are you sure you want to exit? And then we can give them that option to say yes or no. You can do y/n, and then, give them the option, or you can say yes or no, any one you want. You can say yes, and that would mean to exit. You can also explain that to them because users needs to be explained to on what they need to do. And then you can say no, of course, and that would probably mean to restart. So, if they're not still sure, they might want to restart and calculate some other side else. So if the end variable equals to yes, that means if they do decide to exit, then of course I'm going to print a nice message and say, thank you for using the trigonometric solver. So I'm just going to take that message right there and I'll keep the color code same. So thank you for using the trigonometric, right? Trigonometric. So solver, right? Program or system. You can put a system right there and you can even do an exclamation mark instead. And then I'd just like to put some nice ASCII art over here as well. So I'm going to print something like a nice cool ASCII art and then maybe wait for about 2 seconds and just exit the program altogether. So, or maybe wait for about a second. So I will think I'm going to go with a second. And then you can put this exit keyword, which means that the console is just going to exit. However, we can do the alternative of if they decide to say no, then we can just tell them that the program is going to be restarted. So just before we call the start function, remember that we did put everything about our program inside of the start function. If you go to the very beginning of your program, remember we created a function and everything in this program goes inside of the start function. And the whole purpose of creating this function was to give the user the opportunity to be able to reuse the system easily just by saying no, they don't want to exit, they decide to reuse it again. So here we're going to tell them the system will be starting, okay, will be restarting, so they know. And then we can do like a ... here, so like that. And then just before you call the function, you can do a time.sleep, maybe wait for about a second, and then you can call the function, which is the start function, which gets this whole thing to run again. And now, most importantly, before you run this, of course, make sure you also can do an else. This is a very good AI suggestion again, an AI assistant suggestion where it's adding an else block for you, which is if they make an invalid choice. So if the choice is invalid, you can say invalid choice, and then you can exit in this case since we don't have a while loop. But this is a very good suggestion saying if they don't enter yes or no. So this is again another way of data validation. It's going to say invalid choice and you can decide to ask them again, but it's not going to work in the way we had with the while loop because the while loop, what it does is that when you ask them to re-enter, it checks again with the condition. But with the elif statements, it's just independent. It doesn't check again. So even if they re-enter, it's not going to be able to check again if they're entering either yes or no. So in this case, the best solution is just to exit the program. Now after that, just make sure you start your function. because you have to, call your function, sorry. And calling the function means you have to write the name of the function on the same line as where you define the function. Otherwise, this whole program does not run. So we're going to be testing this for all three sides and seeing if we did the right thing and if the program is actually functioning properly and meeting its objective. Oh, I forgot we already called the function. So if you have the function already called at the bottom line, you can just erase any extra line that you have there that you don't need anymore. Just make sure that only the function is called only once. You don't need to call it twice. Now it's time for us to run this program and see how our trigonometric solver is working. And you can actually get a worksheet online for math that is involving trigonometric ratios, and you can be able to enter those values and see if your trigonometric solver is working well, or you can even enter it from the top of your head. So as you can see, I'm going to be testing for looking for the adjacent side, looking for, that's what we have here on question 1, the adjacent side, because that's where we have the angle and the right angle. And then I'm also going to be testing looking for the hypotenuse, and of course also testing for looking for the opposite side as well, which is like on question 5. So we're going to do a quick test and we're going to see if we got the answers correct. Why don't we go on to our quick test and check if we got our answers right. So first thing I'm going to do is I'll take my terminal up and take it all the way to the top, and don't forget to save your program so that this can run properly. Or you can do a Control S or a Command S. Now click the run button, and so it's running, and you can see it starting with the whole same thing that we had, those cool colors. And now I'm just going to try clicking something that is not 1 to 4 and see what happens. You can see it tells me invalid choice. I have to click from 1 to 4. So remember, 1 is that I'm trying to find the hypotenuse side. So it's asking me what side am I given. So if we go back and we try to use this example for example 2, we're looking for hypotenuse. The side that I'm giving is the adjacent side, and it's 60. So that's the side length. And then the angle is 46. So I'm going to go and just put that in. So side given is obviously the adjacent side or adjacent side. So I'm going to put 2. It says enter the side length of the adjacent. It's 60 and the angle is 46. So I've put that in, and let's see what my result's going to be. Calculating your results, and then it tells me my results is 86.37. And as you can see, it is the correct answer because this is rounded to 1 decimal place, so it's 86.4, but that one's 86.37 to 2 decimal places. Now let's get back again and let's see what we have next. So the program does end at this point because obviously, remember, the program isn't going to rerun since we don't give it that option where it asks you if you want to run it again, except if you hit 4 exits. And then you have like that rerun part. So I'm going to run the program again one more time. And now that we're running it again, it's going to start all over again. And so I can now choose a different thing. So we've basically found the hypotenuse. Let's try doing the opposite now. So I'll choose 2. And it says, okay, you're trying to find the opposite side, but what side are you given? So let's get back to this worksheet. If I was to find the opposite side, like on question 5, the side that I'm giving is the hypotenuse and the angle is 59. So let's go back and put that in. So I'm given the hypotenuse, which means number 1, and the side is 59 and 37, and the angle is 59. So 37 is the hypotenuse and the angle is 59. Hit enter, and let's see what my result's going to be. Calculating your results, it gives me 31.72, and according to here, as you can see, is 31.7, again to 1 decimal place. So now let's try the last side. So I'm going to go back again and run this program. If you don't like the way the program keeps having to rerun, or you have to rerun it, you can add a part at the bottom of the code that says, would you like to run this program again? And if they say yes, then they can just rerun. And if they say no, then of course you can exit. But the reason we have it this way is because we provided an option for exit. So that's the reason. Unless you want to basically call the function again, at the end, and that's like where you can call the function again, and that's going to be even better. So what I'm saying is that you can just call the function at the end, and it's just going to like redo the whole thing all over again, and you don't have to even ask them if they want to, restart. It will just work on its own. All right, so I'm going to go to the third option now, and I'm going to now do the adjacent side, and let's get back to the worksheet and see what we have for adjacent. So if you're doing the adjacent side, so let's assume that we are looking for adjacent, so that's question number 1, and we're given the opposite side, and we're given the angle. So the opposite is 10, and the angle is 60. So we're going to go punch that in. So we have the opposite side, and the opposite is 10. The angle is 60. Right, as it's given here. So I'm going to just type in 60, and now let's see what the result's going to be. So it's calculating results again, and we can see that the result's 5.77. So it's basically right because you have to one decimal place, which is 5.8. So the last test would be for what about if we decide to do the exit? So if we decide to do an exit instead of, at some point, I decide to go with 4, which is exit. It's just going to tell me, are you sure you want to exit for yes or no to restart? Okay, so if I say yes to exit, what happens is that's just going to exit and end. But of course, if we run it again and I say no this time, then it's just going to restart the whole program. So if I do 4 again, but this time I say no, then it's just going to restart. But again, like I said, you can skip this part and you can just call the function at the end, and it just gets the whole menu printed all over again. So you can see it's restarting, and I can go back to finding any of my sides again. So this program works completely efficiently, and it works without any errors and any problems. So just make sure you've done it the right way. We've used some exciting features on MarsCode, which is the AI assistant. And now we're going to be moving on to our next programming scenario. The second programming scenario we'll be looking at to create a program for on MarsCode is the linear diner. This is also combining programming and mathematics.
It's not my fault they changed math. Come on, buddy. Come on. I think I understand your math assignment. We still have some time to finish it before you test. So first you want to put all the numbers by themselves. All the variables. That means a plus becomes a minus. And a minus. You got it? Yeah, baby.
The linear equation evaluation system is aimed at assisting users in solving simple linear equations that contain 3 expressions in the format included below. The system should be user-friendly for users to interact with. You will include aesthetic features like ASCII art and ANSI escape color codes to make the console fun to use. Additionally, you will need to incorporate the required Python programming syntax and structure you have learned so far to make the system functional. The format of the linear equation solvable on this system includes an example as 2x plus 40 equals to 95, or 60 plus 3a equals to 78. The accepted math operators are the addition and the subtraction operators. What this means is that you will need to create a system that basically solves simple linear equations in this format, where they put the number in the variable first, and then afterwards the symbol, which is either addition or subtraction for the system, and they put the number after and an equal sign, and then of course a number after. You notice that these expressions in this equations are a total, if you add them together with the sign, you get a total of 8, right? Because 2x is 2, plus, which is 1, so that's 3, plus 2 again, which is again 5, plus 1, that's 6, and then plus 2, that's 8. So in total, the length of the equation is 8, and it has to be in this format for the system to work. And that's the system that we need to create. Or it has to be where the number is first, then comes the symbol, and then comes the number and the variable. But again, in conclusion, the length is also 8 for the second format example. So we're going to be working on creating the scenario in MarsCode. Let's get started.